Welcome to another episode of Terry's Notes, and I am doing over. This is an updated video to the January 2016 paper, question 11. Right, there were some problems with the audio. Okay, so this question is related to vectors. So we have 3 points. They give us the coordinates, and they said M is the midpoint of the line segment AB. So just based on the coordinates they gave us, we know that OA is equal to minus 2, 8. OB is 4, 2. OC is 0, 9. Right? All we've done is written the vectors OA, OB, and OC in terms of column vectors. Alright, so the first part, they want to know what is OB. So OB, we know, is simply 4, 2. We want to find AB. Now, I'm just going to draw A, B, and C. So this is O, A, B, and C. Alright, so we're saying this is OA, OB, and OC. Right, now this is just a sketch to understand what we're doing here. So if you want to find AB, which is this vector here, alright, we're going from A to B, but we can go AO to OB. So we need to write an equation first of all. So AB is equal to AO. We are starting at the point A plus OB. Alright. Now the first time I ever did vectors, it was very confusing, right? But what you need to remember is that I want to start at A and I want to finish at B. So therefore my first vector here, or the first letter, should be A, right? And the last one should be B. And wherever we end, so we ended at O, so we must start back at O. Alright? Only when you do sufficient vector questions, you'll understand what we're doing here. So AO, we know OA is minus 2, 8. Right? So therefore AO will be 2 minus 8. Right? This is in the reverse direction. So if OA was minus 2, 8, then AO should be 2 minus 8. Plus OB. What is OB? OB is 4, 2. So this will be 6, and minus 8 plus 2 is minus 6. Right? And then we want to find OM now. So what is that about M? M is the midpoint of the line segment AB. So M is the midpoint. M is somewhere here. Right? So this is M. And we want to find OM. So we want to go from here to here. So OM, we need to start at O. So we can go OB. Oh, sorry. Actually, it's much easier than that. We can start at O, go to A, and then end up at M. So, alright, so let's do it as OA instead, plus AM. Right? So we want to start at O, we want to end up at M. So therefore we must start here at O, and we must end at M, and we must have a common point. The common point in this case is A. So OA, what is OA? OA is minus 2, 8 plus AM. What is AM? Now M is the midpoint of the line segment AB. We just worked out AB here. AB is 6 minus 6. So therefore AM will be a half of AB. Right? So it's a half multiplied by 6 minus 6. So this will be minus 2, 8 plus 3 minus 3, which will be minus 2 plus 3 is 1, and 8 plus minus 3 is 5. right? So OM is 1, 5. What do they want now? All right, so using a vector method, show that AC and OB are parallel, right? Whenever we are asked to show that two vectors are parallel, we have to remember that AC and OB, they are parallel. In order to prove that they are parallel, we have to show that one vector is a multiple of the other vector. So we need to find AC. Do we have AC? Let's check that. Right. So we don't have AC. So AC is equal to, all right, let's set up our equation here. So AC is equal to AO plus OC. So what is AO? AO is, let's get this right. AO is 2 minus 8. Right, so AO is 2 minus 8 plus OC, which was OC was 0, 9. So OC is 0, 9. So this will be 2, and 2 plus 0 gives me 2, and minus 8 plus 9 gives me 1. Right, so that is AC. So now we need to find the vector OB, but I think we know what OB is already. So OB is 4, 2. Right, so 4, 2, that is OB. Right, so what we need to do is to show that one vector is a multiple of the other. So we can write OB as 2 multiplied by 2, 1, which is the same as saying 2 multiplied by AC. Right, because AC is a vector 2, 1. So therefore we have to say that OB is equal to 2 times AC, and therefore they are parallel, right? All right, so this is how we show that the two vectors are parallel. All right, so now we have another question here. We have a matrix M, which is defined by this matrix here. They want to determine the value of P for which the matrix is singular. All right, when a matrix, if you have a matrix of this form here, A, B, C, D, the determinant of the matrix, let's call this matrix M, the determinant, which is written as this, is A, D minus B, C. However, if the determinant is equal to 0, we say that the matrix is singular. Right? So therefore, they told us that it is a singular matrix. So therefore, let's find the determinant of the matrix M. So 2p multiplied by 1 minus 3 multiplied by 4 is equal to 0. So this will be 2p minus 3 by 4 is minus 3 by minus 4 is minus 12 is equal to 0. So this is the same as saying 2p plus 12 is equal to 0. 2p is equal to minus 12. P is equal to minus 12 over 2. Therefore, P is equal to minus 6. Right? So just note that for a singular matrix, the determinant is equal to 0. Alright, so we have two matrices, A and B, and we want to find 2A plus B. So, 2, what is A? A is 1, 2, minus 4, 3, plus B, which is 5 minus 1, 0, 3. Alright, this is a scalar product, so we're going to take the 2 and multiply by each element inside the matrix. So 2 by 1 will give me 2, 2 by 2 will give me 4, 2 by minus 4 will give me minus 8, and 2 by 3 will give me 6. Plus, I'm going to write back this matrix here, which is B. So this will give me, now we're going to add the elements that are in the same position. So we're going to say 2 plus 5 will give me 7. 4 plus minus 1 will give me 3. Minus 8 plus 0 is minus 8. And 6 plus 3 will give me 9. So this is 2A plus B. Okay. Now we have a matrix. We have B here, and we want to find the inverse of this matrix, right? Now, if we have a matrix M, which is A, B, C, D, the inverse of this matrix is given by 1 over the determinant, right? And yeah, so this, what we do is swap. This is dA, and this will be minus C minus B. Right, so this is how we find the determinant, the inverse of a matrix. All right, so the first thing we need to do is to find the determinant. So the determinant of B is equal to 5 multiplied by 3 minus 1 by 0. So this will be 15. All right, so the inverse now will be 1 over 15 by, we're going to swap the positions of the 5 and the 3. So we're going to put 3, 5 here, and we're going to put a minus sign, so this is 1. Alright, so you can leave the inverse as this, or you can write it as 3 over 15, 1 over 15, 0, and 5 over 15. Alright, or you can simplify it even further and say 1 over 5, 1 over 15, 0, and 1 over 3. Alright, so you can either give your answer as this, this, or this. Right? Alright, so now we have basically this is a simultaneous equation, right? This is the vector B, and we just worked out what the inverse was. Right? So let's go back a sec. What you need to do is now 0. What we're going to do to solve for x and y, we're going to multiply both sides of this equation by the inverse. Right? What was the inverse matrix? The inverse matrix was 1/5, 1/15. So it was 1/5, 1/15, 0, and 1/3. Right? I'm multiplying both sides by the inverse. 15, 0, 1/3, and this is 9, 3. Alright, whenever we have a matrix that is multiplying, so let's say in this case B inverse multiplied by B will give us the identity matrix, which is 1, 0, 0, 1. Alright, now I could multiply it out here. 1/5 by 1 is 1. Alright, and then 1/5 by, hold on. Alright, so the first thing, 1/5 multiplied by 5 will give me 1, and 1/15 by 0 is 0. So then I'm gonna take 1/5 and I'm gonna multiply by minus 1, so I get minus 1/5, and then 1/15 by 3 will give me 1/5. So this will be 0. So what I will end up with is the identity matrix. Right. So what I need to do now is to multiply this out. So the first thing I'm going to do is take 1/5 multiplied by 9, and I'm going to add it to 3 multiplied by 1/15. So that will be, let's see, 1/5 multiplied by 9 plus brackets 1/15 multiplied by 3, and that gives me 2. So this is 2, and then 0 multiplied by 9 is 0, and we're going to add that to 1/3 multiplied by 3, which will give me 1. So therefore x, y is equal to 2, 1. So there, that means that x is equal to 2 and y is equal to 1. Alright, so let me show you how I get this 2 and 1. What I'm doing is taking 1/5 multiplied by 9, and I'm adding that to 1/15 multiplied by 3. If I work that out, I'm going to get 2. And I'm also working out 0 by 9 plus 1/3 by 3, which gives me 1. Alright, just remember how you multiply a matrix. It's row by column. So the first row by the first column, and that's how I got 2. And then I'm going to take the second row by this column, and I'm going to get 1. Okay.